My camera got turned again. All right, as I said a moment ago, today we're going to do the last selected topic. Again, anytime you have questions when you're working on these, because I know when you're bored, you just pick up your packet and work on a couple of these problems. But the last topic is called prefix, postfix, and infix notation. Pre, post, infix. All right. So let's start with the basics. What is infix? A simple infix statement will be something that looks like 4 plus 3, where the operator is in the middle. If you start thinking about all of these, we're talking about where the operator would be located. Some of you are in CPS 162 and you're nodding your head going, yeah, good. I see where this is relevant. It comes in. We've actually used it. So this is called infix. Okay. A prefix is one where the operator would come first. Now, you could tell me the answer to this is 7, and that's fine, but we're not always concerned about what the final answer is. So whenever you're working with prefix, postfix, and infix, one of the things you'll notice is whatever the middle term is, the operator, it moves, but the order of the other two doesn't. Okay. Finally, postfix, the 4 and the 3 are in the same order, but this time the plus comes afterwards. So there's lots of different ways to teach this, and I could give you another example, like 4 plus 2 times 3, and I could go through this and say, all right, so this is my first grouping. This is a left, this is a right, and this is the operator. And then later, this becomes the whole left, this becomes the right, and this becomes the operator. So in a sense, I would take care of these 3 first. And for prefix, it would be plus 4, 2. And I think of that as the whole left when it comes to multiply. And I could do multiply 3. Because these 3 went together first. Then I did this, that, and that. By the same respects, I could go 4, 2 plus. That would be this side of it. Move the operator to the outside and put the 3 there. Now, one of the ways that, that, and I've done that for a long time teaching students, just to think of this as groups. Like that's a group, that's a group, that's a group, and then I have an outer group. And if you like that way, that's great. In CPS 162, we take a look at it a little bit different. And some of you are taking 162, so might as well give you a little bit of a start. We're going to take this and represent as something called a binary tree. And a binary tree will look something like this, where I have the operations 4 plus 3. Okay, it's a binary tree because I start here and it branches in 2 directions, sort of like 0 and 1. Now, this guy is written in infix, 4 plus 3. And when we talk about these 3 locations, we'll refer to this as the left, this as the right, and this as the node. So when it's infix, I go left, node, right. When it's prefix, you notice the operator came first. So this time it's going to be node, left, right, or plus 4, 3. So the only thing that actually moved here is the node. The only thing that moved was the node, okay? And finally, for postfix, I'd be looking at 4, 3 plus. So if I look here, it's going to be left, right, and then node. So that's the way we take a look at it in CPS 162. All right, so let's take a look at this harder one. 4 plus 2 times 3. In order to draw its binary tree, I know I'm going to do 4 plus 2 first, and then I'm going to multiply that by 3. All right, so my traversals. Infix said go left as far as I can, then back up to the node, and then go to the right. So I start here, I go to the left, I can still go to the left. So if I go all the way to the left, I get the 4. Then I go to the node, which was a plus. Then I go to the right, which was a 2. Then I have to backtrack. I took care of the whole left for this guy. So now I take the node times, and I take the right 6. Okay, and again, I know I did all of that before I multiplied by 3. That was infix. That's the normal way. If I look at this prefix, I said it's node left to right. So I'm going to start with a node, which is times. I move to the left. I have a node, which is plus. Then I move to the left, which is 4. Then I back up because I'm done. I move to the right, which is 2. Then I back up because I'm done. Then I back up because I'm done. And now I hit the 3. Finally, postfix, it's going to be left, then right, then node. So I start here at this node, nothing. I come down to its left, start here, nothing, because I have to keep going left as far as I can. I come all the way to here, I hit the 4. I can't go any farther, so I back up. At this point, I know that I need to try to take care of the right after I take care of the left. So it's a 2. Can't go any farther, back up. Now I take care of the node. Back up, I took care of all of the left. Now I need to take care of the right, following this order. So then it becomes a 3, took care of that. And now I back up to the final node and I put multiply. Questions? Let's do another one. I'll give you an expression and you convert it over to prefix, postfix, and infix. So I'm looking at something that looks like this. B plus C times A minus D. Tan is here, that's good. Who else came in late? Dylan is here, that's good. Chad is here, that's good. Mark, are you here? Okay, so no Mark and no Mystery Min Ken, whatever his name is. So I'm thinking if I build this tree, it should look something like B plus C times I just saw that. I didn't catch it completely, Harrison. I just realized that pre and post meaning before and after referred to the node position. Yes. I have infix. I have prefix. I have postfix. Again, left node right. The node is pre. The node is post. So if I do a traversal, does anybody tell me what it is? Travis, you have a guess? This is the easy one
For which one?
for the infix.
I mean, just the expression you read up top, right?
Yeah, it's going to be B plus C, of course, with the parentheses, times A minus D. Good practices, go left, done. Go back, node, done. Go right, done. Go back, node, good. Go right, left, node, right. I think Harrison threw up, I didn't see it. Okay. Somebody have prefix. CJ, what do you have?
X plus BC minus AD.
So times plus BC minus AD.
Yeah, times, yeah.
That's correct. That's correct. And again, here's the B plus C grouping. Here's the A minus D grouping. And then it's the times the left side and the right side. So you can do this node left to right, or you can think of them in groups of 3 like I have here. 2 different ways to do it. Let's see. Node was times. Node was plus. Come here to the left. Yeah, I got the B. I go to the right, I get the C. Node, left, right. The last one,
I believe I have it.
BC plus.
Yeah, BC plus multiply AD minus.
All right. This is easy, piece of cake, as they say, upside down cake. Let's take a look at the first one. Convert that to postfix. Postfix is also known as Polish notation. Now, again, you can draw the tree, or the other choice was think of this in groups of 3. Here's a group of 3, B, C minus, right? I took that grouping. Here's a group of 3. So I want to put this in postfix, A times. Here's a group of 3, D slash E, whoops, excuse me, DE slash, and then the plus is going to jump out to the end. Do you notice A, B, C, D, E, A, B, C, D, E? I didn't change the order of those lefts and rights. Questions? Ba-da-ba-ba-ba. Number 2. Convert the following postfix into prefix. A, B times C, D plus minus E slash. I'm thinking I may have to put this in Infix before I go anywhere. Here's a group of 3. Here's a group of 3. Here is a group of 3. A times B, C plus D minus, then that whole thing is divided by E. So I went from postfix to infix. Now I need to get it to be prefix. A, B times C, whoops, I'm going the wrong direction, excuse me. Times AB plus CD minus slash E. Good. Try another one. What is the value of the following postfix when A is 1, B is 2, C is -3, and D is 4? The last class, some of you were saying, or maybe 2 classes ago, that the digital electronics wasn't printing very well. Well, it didn't come out. Yeah, I went and changed that to a PDF and it should be fine. So remember again that under the checklist, we have all of these. Number 3, A, B minus C plus A, D times B minus slash. A is 1, B is 2, C is -3, D is 4. I know these 3 go together. A minus B. And then I'm going to take that and the C and add it together. These 3 go together. A times D. And then that and the B minus go together. So minus B slash. Let's see, A minus B is -1. This becomes -4. A plus D is -2 minus 2. This is -4. I get an answer of 1. Let me check the chat because I miss it sometimes when I look away. Nathan got 1. Good. Do you think you got it? Do we need to try another one? Do you want to not talk to me?
I think we've got it, but we should keep practicing.
All right, pick another one.
11.
Good. Try number 8. See what you get. solve the rational values for the ordered pair x, y. Notice that one is in prefix equals plus times x2 times 3y19 x minus y 5 times plus 10 plus equals. Huh. What's going on in the second one? Yeah, Nathan's got it. It should be negative x right here, 5y. I think I might have an extra plus in there. Negative x plus 5y. Don't look at me. Equals 10. And y'all are experts on this, right? You can find that answer for me in no time. Y equals, x equals
Y is 3.
3. I hear that. X equals,
5.
yep. You didn't know you were gonna have to do so much math in this class, did you? Questions? Let's do one more. Let's do 11. The expression b caret 2 minus 4 times a times c caret 1 slash 2 slash 2 times a. B squared minus 4ac raised to the 1/2 power, which is the square root, divided by 2a. Translate that into prefix. I want to make sure it goes to prefix. They go together. They go together. I can't read the symbol for exponents. Here, it's just a caret.
Okay.
They go together. So here is prefix caret B2. Then I have, oh boy, no, wait a minute. Wait a minute, I have some order of operations to take care of. I have times AC, and then I have this guy becoming a whole, right? Which is going to be then become times 4. Now I put that minus out front. So B2, I put the caret out front. AC, I put the times out front. 4 times that, I put the asterisk out, or the times out front. And then the minus out front of all of that. Over here is /1, 2. Here is times 2A. I have this guy. So I need a caret out front, and I need a slash out front. Anybody else get that? So this right here is all the way up to there. Then I raise it to the 1/2 power. Then I divide by that. Let me check the chat. We good? I bet y'all didn't get that. You just won't tell me. Should I do it again? Anybody?
Yes, please.
Okay. So here's what my question was. It was parentheses. B caret 2 minus 4 times A times C, which I really didn't need those parentheses. Okay. That whole thing is raised to the 1/2 power. And then all of that is divided by 2A. All right, so I'm going to do this time. What's the first, so when I come in here and I get ready to do this, what's the very first operator that gets done? This guy right here, right? Second operator. Third operator. Fourth operator. Fifth operator. Sixth, 7, and 8. Taking care of the first one, it's caret, that's this one right here. It's caret 2, B2. Caret B2. My second operator is out here, times AC. My third operator is right here. So there's my left, there's my, so it's going to be times 4. My fourth operator is this minus. So I just took care of that whole thing, which was my third op. My minus is going to be all of this minus all of that. So I'm good up to that point. Fifth thing I do, /1, 2. The sixth thing is I take all of this which I've taken care of, and raise it to that power, which is all of that. So there's going to be a caret out front. Seventh is right here, times 2a. The eighth is all of this divided by all of that. So it's all of this divided by all of that. Yeah, I messed up my order up there. Don't look at that one. Alrighty, so I'm going to pause. So the question is, can we do number 23 for digital electronics? Express the following circuit as a Boolean expression, then simplify the expression completely. All right, so I'm actually going to write on here. I don't feel like redrawing it. This is an A. This is a B. Let's see. This becomes, after it comes out of here, what is it? A C naught. And then what's it when I get over here?
It goes back to being C.
Right. If I come down here, this guy, that line up top is an A. This line is a C naught. What comes out of this? So again, I have and I have or. The and looks like a D. The or is like so. And was multiply, or was plus. So this became a not of an and. So correct me if I'm wrong. I get not AB right there. If I come down here, this is an or, so this becomes A plus C naught. This is a C naught, so this is again an or, so I have C naught plus A plus C naught coming out of there. Yeah. What do I have coming out of here? It looks like, again, an and, but I'm going to not it. So C times C naught plus A plus C naught. All of that with a not across it. And then finally, this is the not of an or. So I'm going to get ready and write AB naught, and or is a plus, and then down here I have C times C naught plus A plus C naught, and I want to or not all of that. Oh, went too far. Still too far. So I have AB, the not of AB, plus, and then I'm going to not all of that for the little dot there. I have C times the not of C plus A, the not of C. Did I do it right? Can I get a hell yeah from a redneck girl? Anybody? Thought I saw something pop up. I got not a, I got a little different.
It was just in a different order,
Okay,
but it's same thing.
Okay. All right, let's see what we can do. I'm gonna take a look at this side over here. What is C naught plus C naught? Anything, again, the pluses or anything ORed with itself, what's it give me?
Just one.
It gives me just one, or does it give me itself? Oh no, Mr. Bill. Anything ORed right here with itself gives me itself. Anything ORed with itself gives me itself. So now I'm going to just take a look at what's here. C times A plus C naught. Agreed? Distribute AC plus C naught. What does that become? What does C naught become?
Zero.
0. So now I have AC plus 0, which becomes AC. So putting that back into my original problem, I have the naught of AB plus AC. The naught of this becomes the naught of the first times the naught of the second. The Morgan's rule. Well, this is going to become A plus B, excuse me, times B. Agreed? Times the Morgan's law, naught of A plus naught of C. If I distribute, I get A naught B plus A, B, C naught. What is A times the naught of A?
0.
Yeah, and then 0 times B is just going to give me 0. And it looks like I'm going to be left where I could have simplified that giant digital electronic into something that looks like this. I could have done A over to here with B. Then I could have had C. Could have knotted C, and then I take that and this, and done. Logically much simpler.